Good morning or good afternoon, everybody. My name is Robin Goldsmith. I'll be your presenter today, and we are going to be recording this session. So welcome to Estimating and Controlling Testing Projects. And this is in conjunction with the Software Quality and Test Management Conference that's coming up the end of May and the beginning of June in Washington, D.C. area, actually Falls Church, which is one of the nice suburbs of D.C. And let me tell you a little bit about who I am. So I do actually work with and train professionals in a variety of areas, which I see as related to enabling people to get what they need and get it right. But not just quality and testing, but also requirements, project and process management, metrics, return on investment, software acquisition. Once upon a time, I did real work. A long time ago, was very technical even, starting as a systems programmer and then branching out into more applications areas. And I was a member of two working groups that developed current revisions of IEEE standards, 829 for software test documentation, and the more recent one, 730, on software quality assurance. And I'm pleased to say that the fully revised 730 on software quality assurance standard draws to some extent upon my proactive software quality assurance methodology. I'm a subject expert for TechTarget.com, searchsoftwarequality.com, newsletters, and website, and I was a subject expert for version 2 of the International Institute for Business Analysis body of knowledge. I'm sure some of you are familiar with that. And I am the author of a book called Discovering Real Business Requirements for Software Project Success. Now, what we're presenting today is a preview of a full-day seminar with the same title that will be presented at the Software Quality and Testing Management Conference, and it'll be on Friday, June 5th, full-day seminar. And like all the seminars at the conference, it does qualify for the various IIST certifications. This particular seminar is an elective for basically any of the IIST certifications. Some of you may be pursuing those or have them already. We certainly encourage that. Now, let me share with you what I see as the objectives for today's presentation. Okay, and so let me guess that you're on this webinar because you are involved with testing, and that you probably are asked to make estimates of how long it will take to carry out the testing. And let me also guess that you find that hard to do, and that regardless, you don't get enough time to do your testing. You don't get the amount of time that you estimated, and you certainly don't get the amount of time that it actually takes, because there's a good chance that your estimates are off by some considerable degree. Now, one of the things that we want to do is look at how people estimate their testing now, and what difference it makes how you estimate. And then we want to look further at estimation to analyze what some of the key elements of estimating are and see how they're especially troublesome for testing, and then suggest some approaches that I hope you will find more effective for helping you address some of the biggest challenges of estimating testing. And I'm not going to tell you that your estimates are going to become perfect, but I think that improvement, more reliable, more confidence building, more credible, these are all objectives that you can approach, get closer to as you improve your estimating techniques. So think about what happens. In a typical project, testing takes about half of the time. And yet, in spite of that, we generally don't have enough testing, or the testing isn't catching enough of the problems to give us the degree of quality that we feel we need. And estimating what it'll take to do the testing is a big issue. It's universal. The problem is universal, that people have a lot of difficulty knowing how to estimate. And then regardless, they have a lot more difficulty actually having sufficient time to provide the adequate testing. And the problem is that senior management is not only no better at this, they're probably worse at this. Project managers often are charged with making estimates. Well, project managers routinely are pretty unaware of testing and of what goes into it and what it'll take. But the fact is that those of us who are directly responsible for quality assurance and testing probably aren't helping the situation. We're probably not really adding to it appreciably, so that these other folks, the project managers and the senior management, probably feel entitled to rely on their own guesses rather than ours, because our guesses seem to be just that, guesses. Now, I'm going to ask you folks to participate here and to share with us, and I'm saying chat, but there's actually a box called questions, and so there's one box called questions, there's another called chat. I'm going to ask you to use the questions box, okay? And let's see. Now, there's a question, is the meeting started? And not sure when that came. Can't hear. Is there sound? Can't hear anything. Just see the slides moving. I can hear now. Work breakdown structure. Okay. So how good. People, thank you. You're beginning to respond here. It sounds as if everybody can hear now. So some of the ways that you determine the time and effort needed to test. Okay. So one person said work breakdown structures. We'll talk about them in a little while. Level 0, level 1, level 2 estimates. In our organization, usually the time, let's see here, let me see if I can get this a little bit better. Usually the time allocated is around 1/5 of development time. Okay, so 1/5 of development time, that's a kind of a rule of thumb approach. ROM, Okay. For the first high-level estimate, we use basic development hours. Then it's refined based on the scope and requirements and the work breakdown structure. How long did it take last time? Well, that's interesting. Of course, you're not testing what you tested last time, and there's a real issue of how much this project relates to that. It may. 50% of development effort. Well, here's somebody who's already got a better crack at it than if you've only got 20% of development effort. Okay, our team submits an LOE, level of effort, for levels of effort and the time needed. Level 0 estimate created based on the evaluations of features needed to test. Okay. How many people are needed to test? About 45% of development time. We generally do 30% of development time. Okay. Like an upgrade, how long did it take last time, and so forth. Okay. And test cases, quantity estimation, 50% of development time for level 0, and so forth. Okay. So we're seeing, thank you all, this is really helpful. We're seeing a lot of answers that many of them are based upon taking the development estimate and then applying some kind of a percentage. We saw numbers that range from 20% to 50%, and obviously that creates a much, much, much different situation for the testers. And then there are a number of responses about different levels of estimates and the work breakdown structure approach. Doesn't necessarily get to where those levels or where those estimates come from, but we'll talk more about that as we go forward. So let's get into some general principles or concepts of estimating. And regardless of what we are estimating, the thing that we are estimating is referred to as the target, and all estimates involve relating the target to be estimated to some presumably known reference. So the reference should be similar in nature to the target. And one of the questions is, are the reference and target really that similar? So for instance, if I'm going to estimate how long it takes to build a house, and my reference is kind of a ramshackle old place, and my target is a fancy new two-story place, very elegant and so forth. Well, what it took to build the ramshackle place might not translate directly to what it takes to build the different place. Okay? And that can change dramatically if it becomes a very modernistic place and so forth. So there can be big discrepancies when the target and reference are not all that similar. The size and complexity. Do we have a way to know the size and complexity of the reference? Do we have a way to know the size and complexity of the target? And do we have a suitable way to scale them? And do we actually know what it took in order to accomplish the reference, okay, or what it should have taken, because maybe there were other factors that came into play? Now, I would contend that when we look at estimates of testing, that there's a pretty good chance that most of your estimates are based upon no answers to the 4 questions at the bottom. So we shouldn't be surprised if the estimates of testing turn out not to be very reliable or very accurate. So let's look at 10 reasons that I've found why estimating usually fails. First of all, there are a lot of folks and a lot of organizations that have the attitude that the estimates don't really matter. Okay? So if you're in an organization that has attitudes like that, or if you work with people who have attitudes like that, or heaven forbid the person you see in the mirror has attitudes like that, well, you shouldn't be surprised if not only do you think the estimates don't matter, but in fact they don't, because they are just way wrong. There's a common tendency to have knee-jerk reactions. People say, nope, we don't have time, let's just cut features, okay? Or let's cut quality, let's cut testing, which is a way of cutting features, because if the quality's not there, the feature isn't there. And ironically, people often don't have commitment to making their estimates come true. So there are 2 general schools of thought on estimates. One is that there's somehow a magical way to get the objectively accurate estimate. The other school of thought says the estimate becomes accurate because you do things to make it come true. Now, in fact, a combination of those 2 is most practical and most necessary. But the estimate isn't accurate until we make it come true. And if you have, as so many people do, the belief that it's impossible to estimate, then I would contend that that becomes a self-fulfilling prophecy. Now, these are all attitudinal issues, and some people, some organizations know for a fact that it's impossible to estimate, and other people and organizations with identical factual situations believe that it is possible to make reasonable and accurate estimates. Ironically, the folks who believe do make accurate estimates, do make estimates that they can deliver on much more reliably. The people who believe that it's impossible to estimate continually prove themselves correct. Now, these attitudinal issues you need to be aware of them. You need to work on them. One of the reasons that they exist, though, is because of the mechanical problems that tend to afflict estimating of any type. And it's the mechanical things that I want to focus on today. And they tend to fit in a big category called overlooking things. So if we overlook deliverables, that's largely driven by not knowing what the requirements are. If we overlook the tasks necessary to create those deliverables, if we overlook the various constraints and practicalities and parameters and uncertainties and contingencies and change. So we've got a whole bunch of things here. Practicalities, we'll talk a little bit more about that in a minute. Okay. But overlooking things, that's a mechanical issue. And that's something that we can actually improve upon, and just becoming more aware of the types of things that tend to be overlooked. Okay. And then, once we have a more reliable basis for our estimates, actually taking the actions to make them come true, and paying attention to what happens. So we need to measure not just the estimates, but the actuals. Okay? Now, overlooking is the big issue, because anything that is overlooked is not going to be estimated. Okay? And things that are overlooked then affect these other issues: similarity, scaling, sizing, and our ability to have known effort and duration. So overlooking things becomes the big bad guy, the mechanical issue. There are two major approaches to estimating. Top-down, okay, where we make a single estimate for the whole thing and then we allocate it among the major parts. Now, a few minutes ago we used the example of building a house. Any of you who are familiar with home construction, house construction, know that contractors routinely estimate based primarily upon square footage of the house and then adjust that based upon the style of the house and the type of materials that are going to be used and degree of luxury and things like that. But basically, they use a small number of parameters to go against a huge database of historical data on what it takes to build a house, and it's largely driven by square footage. And then, based upon the style of the house, they then take that total cost and allocate it various percentages, for the various components of the house. And by and large, contractors generally are able to estimate pretty accurately. Now, are there differences? Are there situations where there are factors that they didn't anticipate or didn't take into account? Absolutely. But top-down estimates are probably the most common way that budgets and schedules for testing are set. Okay? And they're usually set by somebody who doesn't have a whole lot of awareness of testing. Okay? Call them management, call them project managers. And very often, these top-down estimates of testing are created using some kind of a rule of thumb, just as you folks mentioned, some percentage of estimated development effort. You folks were talking about ranges anywhere from 20% to 50%, okay, and like that. And so there's a question, can I please show a previous screen once more? I'm sorry, but I'm not going to be able to do that right now. We kind of have to move forward here to keep within the time frame. I'm sorry about that. So, rule of thumb. Okay. Now, this tends to be done in a couple of different ways. One way is per component. So there's an estimate for building a particular component and then an estimate for testing it. Okay. A variant is that the development estimate is based upon each individual component, and then there's a single lump total for testing, okay, a testing phase. Some of you undoubtedly are familiar with one or the other. Your 20% and your 50% could have been applied in either way. I think you can imagine that the percent applied to each component somehow is going to turn out to be more accurate than when the components are estimated individually and then the testing for them is all lumped together. Now, Remember we said, is the reference similar to the target? Well, development effort estimates of development have very little to do with estimates for, the testing. Okay? Development and testing are not that similar. Yes, the more that's developed, the more testing there's going to need to be. The more complicated the development is, hopefully the more testing there will need to be. But the fact is that development effort is not a very reliable basis for estimating needed testing effort. And unfortunately, all of these things tend to turn out to be the testing is simply given the time left after development gets done. And the time left has absolutely nothing to do with the relevant needed testing. So top-down estimates, the advantage of them is that they're quick. The disadvantage is that they're generally inaccurate, and they're inaccurate because they tend to overlook all kinds of stuff. And everything that is overlooked is not going to be included in your estimate. And top-down estimates tend to overlook lots of things, and the people doing them don't have much of an understanding of what they're overlooking. So let's see. Somebody says the volume just went out. Let's see. Can anybody indicate, send me a yes so you can hear note on the questions? If you can hear. Okay, some people can still hear me fine. Okay, thank you. Okay, so I'm not sure what your volume issue was there. I apologize if it was on my end. Okay, so great. Lots of people can hear. Okay, and so somebody, Cynthia said she's on the phone, not on the computer. Okay, well I'm not in a position to debug the audio at this point. I'm sorry about that. It sounds like most of you can hear, and if you're not able to hear through your computer, there is a telephone number that you can dial into. So the problem is that estimates that are based upon development generally have very little to do with the testing that's needed. And there are some other issues. That those ratios or rules of thumb very seldom get adjusted based upon relevant factors, things that might affect how much testing you need to do. So for instance, if you are indeed reviewing and inspecting requirements, designs, code, those techniques are probably going to catch a lot of problems that if you don't have those reviews are going to end up making the dynamic test execution much more difficult. If development is doing a better job at unit and integration testing, then you're going to be relying less upon the downstream, especially system and acceptance testing and so forth, to catch problems. And I don't know about you, but I find that most people these days have to worry about security, they have to worry about load or performance testing, they have to worry about usability, and all manner of other types of special tests. Well, each one of those imposes considerable demands on your testing. And these things relate to the sizing and the scaling, and if they're not factored in, then you shouldn't be surprised if the ratio or rule of thumb is just totally irrelevant. And here's the other issue. I'm sure you're familiar with reports like the Standish Group's Chaos Report, and they've been issuing these since 1995. The 1995 one is the most well-known, which they found that 31% of major projects are abandoned, that 53% of projects are on average 222% over schedule, 189% over budget, and that the only reason that they're able to finish it all is because they only deliver 61% of promised functionality. So is the development estimate at all relevant to accurately predicting anything? Probably not. Developers don't estimate their development accurately. A percentage of a wrong development estimate is going to be wrong for testing. And basically what happens is that when you use a ratio, there's no real commitment to that testing estimate that comes out of the ratio. Okay? And you know, it's real easy when you get squeezed to say, well, I need a month of testing for a month of development. Well, no, I don't have that time. I'll do a week of testing for a month of development. Well, I don't have that. I'll do a day of testing for a month of development. I'll do an hour of testing for a month of development. Okay? I mean, it's real easy to slip your basis. Okay? And developers' perceptions, and by the way, projects, top-down testing estimates tend to get created by people with a development slant and a development influence. And developers just really tend not to have at all a good understanding of how much testing is actually required. Some of you may know Ross Collard, a good colleague, a longtime colleague, one of the top guys in the testing community. And Ross has shared with me that a report that he was aware of, that developers typically think the test effort should be somewhere between 20 and 33% of the development effort, similar to what one person said earlier. IBM, which has been known to actually measure stuff and look pretty well at what they're doing, said the testing actually takes about 3 times the development effort. So even if you're up at 50% of the development effort for testing, you're off by, you know, orders of magnitude. Now, to be fair, your results may vary, but there's a pretty good chance that you probably don't have a good grasp on the actual relationship between amount of testing and amount of development. So let's see. I had a question. What is GIGO? Garbage in, garbage out. Okay, that's what it is. Garbage in, garbage out. So if you are basing your test estimate upon an estimate of development, and the estimate of development is garbage, which is usually the case, as the chaos reports and others have tended to tell us for years, and your own experience probably as well, you don't have a prayer of coming up with a reliable or accurate test estimate based upon a nonsensical development estimate. Okay, so thanks for your question. Okay. Now, the alternative is to estimate bottom up. So with top down, you take a single estimate and allocate it among the pieces. With bottom up, you identify the pieces, make an estimate for each one, and then roll that up into various higher level aggregations. And this is where a work breakdown structure typically comes in. A work breakdown structure is simply the name given to the definition of the various tasks. And a work breakdown structure is hierarchical. So in this simple example, let's say that testing web configurations consists of two subtasks, preparing configurations and running the tests. And when we do a work breakdown structure, what we do is we decompose the work down to low-level tasks that a single resource can accomplish, typically in a week or two or less. Those are referred to as work packets. And so the prepare configurations actually consists of the defining the components, the acquiring the hardware and software, installing it, installing the browsers, and so forth. Okay. And so what we're showing in the parentheses are the totals of the included or below tasks. So if you add up all of the these four work packets for the defining the components and so forth, you'll see that they total up to 80 total hours for preparing the configurations. Running the tests, we have 3 techs, each doing 10 hours, so that's a 30, and the total of testing the web configurations is 110. And the good news is that bottom-up estimating tends to be more accurate because it tends to spot overlooked tasks. The bad news is that it takes somewhat more effort than just pulling a number out of some bodily cavity and using that for a top-down estimate. Now, for each work packet, we make an estimate of the effort and the intrinsic duration. Now, intrinsic duration is the elapsed time that's necessary to do something. Very often, it's the same as the effort, but sometimes there are elapsed times that just take a lot longer. And we make those estimates for a defined skill and level and for prescribed quality levels, both incoming, which is referred to as defect density. So you know and I know that if the code that you get is all full of defects, it's going to take you a lot longer to test it than if it's clean code. But you also have outgoing quality levels. So if you're doing something that has life-critical consequences, you're going to need to test it more than if maybe it's just keeping track of your recipes for snacks at the Super Bowl party. Although maybe that's the more critical issue. But what's the problem? Well, do we have good ways to anticipate incoming defect densities? Do we have agreed upon outgoing quality requirements? So these are issues as well. Now, if we think back, let me go back here, 3 technicians, each doing 10 hours, probably working together for 10 hours, total of 30 hours. Well, that estimate ultimately becomes the basis for errors and questions, because it really comes down to what tests are going to be done in those 10 hours. Okay? What's the size of them? What's the complexity of them? Boy, none of that's necessarily defined. It should be, but that's the type of information that's needed to make sure that estimate of running tests actually has a reliable basis. Now, the fact is, running tests consists of a bunch of tasks. Okay? And if we're not aware of those, okay, then we're going to be wrong on things like the resource, skills, and level to do each task, okay, the effort and cost per task, the intrinsic duration per task, and if we're not clear on all those tasks and subtasks, then we probably don't have a legitimate or reliable basis for knowing what the reference took. Okay? We may, in fact, be trying to project based upon references that were entirely different. Okay? And then there are additional practical issues related to extrinsic duration factors. When can a task start? When can it finish? What else might be involved? And so forth. So just because we're going bottom up does not mean that we have necessarily overcome these basic issues of similarity and scaling and knowing what the reference was. To be fair, going bottom up tends to reduce the impact of any given error in this regard because we're breaking it into more pieces. But the fact is that we may not have reliable similarity, scaling, or awareness of what the reference took for any of those pieces. Okay? And so we tend to delude ourselves, and we somehow think that 3 technicians for 10 hours each is somehow a reliable estimate, and it may be total nonsense. Not saying it is, I'm just saying that that's as big a risk as something else. So let's look at this from the standpoint of lack of awareness, things that are overlooked. So if I don't know of half of what needs to be tested, and I don't know half of the tests that are needed for the things that I am aware of, and I don't know half of the tasks to carry out the tests that I'm aware of, and I don't know half of the other tasks that I also need to perform, and I don't know half of what the reference actually took, well, you can do the math here, folks. 50% times 50% times 50% times 50% times 50% turns out to be what a colleague of mine used to refer to as the square root of squat. In other words, it's just nonsense. Okay? If you don't know the information, garbage in, garbage out, boy, you should wish you had some garbage. At least garbage tends to be pretty tangible. So, just some conventional wisdom. What people tend to do, you make your best guess and multiply by 2. Okay? And unfortunately, there are a lot of supposed gurus that give this advice as if it is good wisdom. Well, I add facetiously, then double it. Now, the fact is, it's still probably nonsense. Okay? Doubling nonsense is probably closer to the right answer than not doubling it, but it's probably still way far off. Okay? You can't rely on these superficial techniques. Okay? Now, here's another supposed bit of wisdom that a lot of gurus tend to give you. Always estimate in ranges. I bet a lot of you have heard that. Well, what could possibly go wrong? Well, when I estimate in the range, I think I'm going to get the maximum, and they think I'm going to need the minimum. I've just set myself up for failure. Oh, and by the way, there's a pretty good chance that neither the maximum nor the minimum has anything at all to do with what's really needed. But I've now given the illusion of precision, and I've got nobody to blame but myself for making the bad situation worse. Okay. Now, so I'm going to suggest that if we're going to get more accurate at defining and at carrying out our tests, that we need to get better at identifying what needs to be tested. And we need to realize that testing is there to help us control risks of the system or software product that's being produced. Now, traditional testing, I would contend, is reactive. It tends to start with the software, creates a bunch of test cases, and then prioritizes them by the risks that they deal with. Okay? Now that's not entirely wrong, but it sure isn't entirely right. For one thing, test cases represent small risks. And when you're zeroing in on small stuff, well, what do you tend to miss? You tend to miss the big stuff. So what I refer to as proactive testing comes at this in an entirely different way. Reactive testing tends to create tests and then analyze and prioritize those tests based upon the risks they address. Proactive testing starts by identifying the risks and using powerful techniques that help spot many ordinarily overlooked risks, especially the large risks that when they are overlooked turn into showstoppers. And they often are the subject of what are called detailed test plans. They're big. They stop the show if they go wrong. And they go wrong and stop the show when they're overlooked. And then we analyze and prioritize those large risks and focus on the higher large risks and identify medium-sized risks related to them. Those are the topics of what are called test design specifications. And then we analyze and prioritize those, and for the test design specifications that are dealing with the highest risks, then we identify the small risks, the test case size risks, that taken together will help us have confidence that the medium-sized risks work and that, in turn, that the large risks work, or don't come true, shall we say. Those are the test cases. So when we get proactive, we start with risk, large, then medium, then small. Okay? Tends to be a much, much more effective technique. Okay? And then we spend our time creating only the most important small test cases, but the importance is determined before we do the heavy lifting of creating those test cases. Now, test design is what we do to identify two things: the set of test cases that's needed to demonstrate that things work, features, functions, capabilities. We can use templates and checklists to help with this, but I caution you against over-relying on templates and checklists because they tend to substitute for thinking. You need to apply your brain more than mechanically, relying on templates and checklists. And then identify units and integrations and special tests and system tests based upon the small, medium, and large risks. Okay? And then test design also says, for these tests that we're going to be doing, how should we go about doing them? Now, hopefully this is making sense. And so let's ask you to do some more work. Once again, chat in the question box, if you will. Tasks that have to be performed to do any test. Now, there's a good chance that you may not think in these terms, but in fact, if you step back and look at the way that you do testing, there are a bunch of tasks that you're going to have to do regardless of the type of test that you're doing. So just says environment setup, okay, and that could be true. Okay, it's not going to typically be on a per test basis, but indeed we may have an environment setup, prerequisites. Okay, so when you say prerequisites, I suspect that you're identifying prerequisites for carrying out a given test, ensuring you have good data, okay, when you're testing. Yeah, good. Okay, any other? Yes, okay. Identify the test scenarios. Yeah, okay. Anything else? Any other tasks that you have to do? So you're identifying the scenarios and the environment and data. Anything else? Okay. So let's see. Strategy, data setup, test case design, defect mitigation if needed. That's a fancy term. Okay. Positive and negative data, good. Risks and assumptions and dependencies, user setup, account setup, passwords, things like that possibly are needed, okay, and so forth. Okay, now notice what you've just done. You've just identified, I don't know, like 10 different tasks that are involved in practically any type of testing. Well, I would suggest that when you're estimating those 3 testers for 10 hours, that you're probably not really thinking about any of these 10 things except the actual test execution time. Okay? And gee, there's just a whole lot of stuff that goes on besides physically running those tests. Okay? So we can use some kind of a template or a skeletal work breakdown structure, and this is not meant to be exhaustive, only to give you an inkling of some of the tasks that probably apply to each of your tests that probably are not thought of. So you physically have to create those tests, right? And to do that, and some of these are things that you mentioned. You've got to identify the conditions that you've got to demonstrate. You've got to define input values. You've got to determine expected results. You may have to build data records and so forth. Okay? You actually have to run the tests. Oh, and then you're going to have to rerun the tests for a certain number of cycles. Typically, a cycle means that you run tests, find defects, report them back to the developers. The developers presumably fix them, send you a new version or new build or whatever your term is, and you do that again. Now, there's a pretty good chance that most of you do not know how many cycles it typically takes for you to get your testing done. Probably more cycles than you realize. Now, I've had students who come from organizations where they in fact measure or tell me that they measure, and I will believe them. And some people say that they have as few as 3 test cycles. And one said they use 13 test cycles. It typically takes them about 13 tries to get through all their testing. Now, there's a pretty good chance that your estimate of how long it takes to execute the tests is based upon one test cycle. So if you've got to do it 3 times, you're probably overlooking 2 of those test cycles. If you've got to do it 13 times, you're not even in the ballpark. Now, when you're running tests, the fact is that executing the test is typically the shortest or the smallest portion of what goes on. The thing that takes time is defects. So we have to analyze our results, and when they are defects, then it takes additional effort, okay? Additional time to do what's called defect isolation, which means identifying what went on that led to the defect so that the developer can reproduce it. Because if the developer can't reproduce it, the developer can't fix it. And then actually writing defect reports, which can be very time-consuming, and then what's called defect advocacy. And guess what? That's a big time taker. Okay? Defect advocacy means arguing on behalf of the defects, because what you think is important, your users, your manager, developers, and so forth often don't agree. Now, if you come up with some profiles for groups of tests, of simple tests, of complex tests, of load tests, automated tests, whatever groupings make sense, come up with some representative measures for each of these tasks, that's going to give you the basis for estimating the test-based tasks. But then there are other tasks that are not test-based. Test-based tasks say that if it takes you 10 minutes to run a test and you have 10 of those tests, it's going to take you a total of 100 minutes. But there's this other stuff that's not test-based. Maybe you can think of some other tasks, administrative and support types of tasks, that also have to be done, and the time that it takes to do them has nothing to do with how many tests you've run. Status reports, creating your test environment. Okay? Anything else that anybody can think of? Okay. You know, if you've got meetings, if you've got training, if you've got tools, setting up tools, learning about them, okay. These are all time-consuming activities that are not a function of the number of tests that you've got. Okay. Now, I've just put in a handful of examples of tasks here, but you can use the spreadsheet. Okay. So set up a spreadsheet for each type of test that you've got, a row for each task, and I just put a couple of them here so that it was readable. Okay. The number of tests. Okay. So you estimate the effort and the intrinsic duration for carrying out each task per test. And then you let the spreadsheet extend that effort and duration, multiplying by the number of tests of that particular type, okay, and so forth. And now what are we doing? We're coming up with a much more reliable basis for our estimate. So when somebody says, well, gee, you don't have 210 minutes to do this, do it in 60 minutes, you can say, well, which of these tasks don't you want done? Or which of these tests that we need to demonstrate to be confident it works, which of those are you going to do without? And now everybody can see why we're doing the tests and where our estimates are coming from. And if you miss a task, it's going to be out of 210 minutes, not, out of 0, basically. So if you overlook a task, you've got the opportunity to insert it in that spreadsheet and improve your estimating as you go forward. Oh, and then we actually have to capture what went on, what actually happened. Well, look what's happening. It appears as if our estimates tend to be off by about 50% reliably. So we now are in a position to either go back and re-estimate at a more accurate scaling, or we have to cut down on the number of tests that we're doing, okay? Or find ways to do them quicker. But when we know what we're doing, we're in a position to both be more reliable and communicate more credibly. So, what are we doing here? Well, we're making an estimate of the testing in an understandable, positive way. We're providing an appropriate reference and an appropriate basis for scaling. Okay? Templates can help us reduce the number of things that we overlook, both test-based and non-test-based tasks. And then it gives us a basis for capturing the actuals in a more granular manner so that we can better tell where our estimates are on target, where they are not, and we can guide suitable adjustments, and we can do that early as we're going forward rather than having to find out at the end how much trouble we're in. Okay? And the recalibrations could be all kinds of things. Maybe the person who's carrying out the test doesn't have the necessary skills or the resources or the tools or whatever. But when we can see what's involved, then we're in a position to make more meaningful estimates. So it's doing the work that takes the time and resources. And the fundamental basis for estimates is the number of units of work times the time, that's the elapsed time or intrinsic time, and the effort per unit of work. Okay? And we can use that in the form of parameters that can be confirmed and can be adjusted. And we can then incorporate factors to account for uncertainty. Generally, things that are closer in time we need to know more about, and we can know more about. Things that are further out, we tend to have to factor in greater uncertainty. And then we need to monitor the actuals. We need to detect variances. We need to analyze and adjust based on them. It may be finding overlooked deliverables or tasks. Could be parameters, the number of units, or maybe they're not estimated correctly. Maybe the effort per unit is not estimated correctly. But the fact is that because we've got this detail, we're in a position to make meaningful adjustments and, more importantly, communicate meaningfully. So hopefully you've seen some ideas on how things are currently done, and possibly understanding why some of your current methods might be leading to results that you don't like. Helping you see the key elements of estimation. You've got a target and a reference, similarity, scaling, and actually knowing what the reference took, and suggesting some more effective approaches. First of all, coming top-down in terms of risk, but bottom-up in terms of the tasks to carry out the testing, realizing that there are test-based tasks and tasks that are administrative and support, and we need all of them. So I thank you for your time and attention. I hope you found this helpful. I'll be glad to stick around here for a few minutes and take any questions that anybody might have. I think I've been able to keep up with them. And I really appreciate your participation. You've made this very helpful. So don't forget to register for and attend the Washington, D.C. Software Quality and Test Management Conference. And especially don't forget to sign up for my seminars. Okay, I'll be doing 3 of them, this one on Friday and 2 others that I've already done webinars on. And I will tell you that the recordings of these webinars will be made available, and some of them are already available, both on the IIST.org website, and I've just heard that they're also getting put up on YouTube. I'll also encourage you to remember that IIST presents public training at various locations throughout the year, and we can come to you to present training in-house at your convenience. And many of our seminars are also recorded, and you can find out about that on www.iist.org. Okay. So we're seeing a bunch of people who are saying, I will surely use these techniques within my organization's projects. Fantastic. Good luck. And if I can be of assistance, I hope, don't hesitate to contact me at robin_goldsmith@iist.org. I hope to see all of you in future IIST events, both the SQTM conference, the training weeks, the recorded sessions. So thank you very much. Good luck with it all, and hope to see you all soon.